So this video, especially for Seth. Sorry, Seth, feel better. All right, purple paint. Of course, it's peculiar that I wore my purple shirt to talk about our purple paint proportions today. Lots of people. I mean, I knew this lesson was happening, and I just like purple. So, when we mix paint, who's in art? Like visual art, like not digital art, but like the art class. Yeah, with Miss Whitlatch. What are your primary colors?
Red, blue, and yellow.
I knew that.
Red, blue, yellow, right? Now, why do we call those our primary colors? Olivia?
Because you can mix them to make any color.
We can mix them to make essentially any other color. Now, we have a... Gentlemen, is there an issue back there I need to help with? Who?
James.
Figure it out or you're sitting somewhere else. Like, not you. I'm talking to James. There's 4 spots at that back table that you can stand at as well. So, when we're mixing colors, there's really only 3 colors. Really, like when you get down to it, there's only 3 colors. Every other color is a mixture of those colors. So we've got the primary colors, there's 3 of those. We've got the secondary colors, and then the secondary colors, mixing those and primary colors, can make pretty much any other color you can imagine. But the thing is, when you make a color of paint, and when you mix multiple colors together, like let's say I go to the store, and I get a 5-gallon bucket of purple paint. It uses 2 gallons of red and 3 gallons of blue. What did you just do?
Put a Sharpie back.
Oh. I didn't know what you were doing at my desk. Then, if I need to go back and buy 10 more gallons, well, I would need to double my red and double my blue to keep that relationship being proportional. So the big thing here and why we use paint to reference is if we got slightly off. Like let's say we started and we used 2 to 3, and then we used 4 to 5, because let's say we only wanted like 9 gallons. That's not equal. It's not proportional, and it would not give you the same color. You'd have too much red there, not enough blue, and your color would be off. That's exactly why when you go and you mix a color of paint and they like really say, well, how much paint do you need? Even if you go back to Home Depot the next day and say, oh, I need 1 more gallon for that project I started yesterday, it might not be perfectly the same color because the computer might mix it, like it'll try to mix it the same exact way, but we're talking like drops. Like the amount of drops of dye that goes into it is the ratio that determines it. So if you ever if your parents go to get paint or whatever, go watch what happens. They put the can in, it's like white or like an off-white, and then the computer spits in all the colors, and then it just shakes it around and makes the color. Actually, if you go to Ace Harbor up here on Hard Road, they do it all manually. They set like a little dial and they say, I want this much blue, I want this much red, I need this much yellow, and it does it all manually. And then they put it on the shaker and it shakes it all up.
So is paint like clear?
Most paint is white just to have some kind of pigment to it. Because if you started clear, it'd be very hard to make it a color. It's easy to take white and turn it into a color. Like just add dye, add color to it.
It's like no color.
Yeah. Yeah, most of it's just like white. So the big thing with looking at tables. Now, if you think back to that paint situation.
2 quantities, x and y, have a proportional relationship if y is always a constant multiple.
When you think back to that paint situation, how much blue and how much red would you need to buy 0 gallons? What, Ella? 0, right? If you're buying 0 gallons of paint to mix up 0 gallons, you would use 0 of blue and 0 of red. That's what's going to exist anytime we have a proportional relationship. There's going to be that 0, 0 point, and then every time the x goes up by a certain amount and the y goes up by a certain amount, it will always stay the same. So if we call our circles here our x, my smartboard's off, and my squares here my y, if I double my amount of circles, what will happen to my squares? Nate?
Oh, they'll double too.
They'll double too. So if I then turn this into 4, yeah, my smartboard's goofed up. Give me a second to try this. Even when I center it, it doesn't stay centered. So if then I turn it into 4 circles, I have 2 squares. What if I then have 6 circles? 3 squares, and it just continues to go like that. Because anytime I would simplify this relationship, I would still get 2 compared to 1. I always have 2 circles for every square that I have. That's essentially the basics of a proportional relationship. So the first thing we're looking at is in tables. Then we're going to look at in graphs. So there's specifics of when we get to the graphs that are slightly different than here. So look at this table you have here. We know, so first off, because this is in your notes, but it's not in digits, up at the top it says x and y have a proportional relationship if y is always a blank of x. Karen? Yeah, so you can either say multiple or constant multiple. So y is a multiple of x.
I don't know. Get it? Why?
Another way that we call this is direct variation, when 2 quantities vary directly. So side length and perimeter are very easily related when talking about a square. Why is it so easy when we talk about a square? Somebody knew, Sheed?
Because the side length and the perimeter are 2 different,
So make sure you think it through before you raise your hand, Jackson.
All the side lengths are the same, and it's always going to be the exact proportion. Because it's like on first square, it's always 1 multiplied by 4. It's not an uneven number.
Yeah, what makes up the perimeter of a square? Well, we know it's a square because it has 4 sides. So our perimeter, really, if we think about this, is I have 4 sides all the same length. It's just 4 times s, whatever your side length is. Because when I have a side length of 2, what's my perimeter? 8. When I have a side length of 3, my perimeter is 12. If my perimeter is 16, my side length must be 4. If my side length is 5, my perimeter is 20. And if my perimeter was 24, my side length would be 6. Now, don't just write the simplified ratios. In the bottom here, my first one obviously starts at 4 to 1, perimeter compared to side length. And then the second one's done for me, but my third one here would be 12 compared to 3, which would simplify to 4 to 1. Yes. Yes. My next one is 16 over 4, which again reduces down to 4 to 1. I get 20 over 5, which reduces to 4 to 1. And 24 compared to 6, which again, surprise, surprise, reduces to 4 to 1. This, if you have space on your notes, which you do off to the right there, this relationship, our whole y compared to our x, is what we call our m value, which the specific name for that, which we'll talk more about tomorrow, is the constant of proportionality.
It's basically what you can simplify down to.
It's a fancy way to say multiple. Constant of proportionality is seriously just a fancy way to say multiple. Because it is the constant value that makes those proportional. So here, it's 4. My perimeter is proportional with my side length because it is 4 times my side length. So right below that where it says, does the table show a proportional relationship? Yes. And the reason why is all my ratios are equivalent. So yes, it is proportional because equivalent ratios. Try the next one. But the next one is dealing with area, not perimeter. So think about the area, but it's still a square. So area is still the side length squared. Fill in your table, and then figure out those ratios at the bottom in their reduced form. If all the ratios reduce to the same ratio, it's proportional. So Zach had his table filled in pretty darn fast. Now I kind of gave a little bit of help up here. Area is the side times the side, or the side length squared. But Zach, if the area, or if the side length was 2, my area is
4.
Side length 3.
9.
Side length 5.
25.
So then this is where things get peculiar. What's your ratio for that first square? Zach, keep going.
1 to 1.
1 to 1. The ratio for the second one's already given to us, reduced down to be 2 to 1. We'll start calling people, I guess. Ella, what do you get for that next ratio?
9 over 3 is equal to 3 over 1.
9 over 3, which reduces to 3 over 1.
5.
Leah, what do you get for that next one?
16 over 4, which reduces to 4 over 1.
16 compared to 4, which is 4 over 1. My next one, most of us, I think, could see it.
5 to 1.
25 over 5, which reduces to 5 to 1. And my last one reduced 6 to 1. Is this proportional?
No.
But look, there's a really nice pattern. 1 over 1, 2 over 1, 3 over 1.
They're not equivalent.
Doesn't matter to me.
It doesn't matter. They're not proportional
It's not that
because all their ratios are different. So I'm just going to say no equal ratios. And you could have actually figured that out real easy by saying, how do I find the area? Well, I find the area by doing the side length times itself, not times a number, but times itself. For this to be proportional, it would have to be like my one value equals something times my other value, but it has to be a constant. It has to be a number. Yeah.
Are we in this chapter? Are we doing like proportional relationships with like triangles instead of?
What do you mean?
Can you do other like areas of shapes?
Most of the time, area is not proportional. It might have like a standard relationship, but a lot of times it's not proportional. So let's try these 4.
A table
tables
can be
here.
used to show a proportional relationship.
That's really loud on the video, which is also why I feel really bad. So this is the first one. I rearranged your notes to look a little different, so it was easier to see. This is the first table on the left there. Another way to check proportional relationships is what multiple could we use? We always want to say, and I would write this somewhere, y equals multiple, or you could just put like number, times x. We always want to try to see how could I represent this with an equation where that multiple is some number. So if I'm looking here at my y quantities, well, my first row, how's y compared to x? Ella?
X comes to
Yeah. Ella looked at, well, how do I get from x to y? It's 2 times. So right now, I'm thinking that this table can be described by y equals 2x. See, does that hold true? On the next row, is it true?
Yeah.
On the next row, is it true?
Yeah.
On the last row, is it true?
Yeah.
Yeah. So is this table proportional?
Yes.
Yes, and below it, if you haven't written it down yet, you need to write down this formula. Yes, it is proportional because y equals 2 times the x. For those other 3 tables there, I want you to figure out, is it proportional? And if it is, you have to have the equation for how we find the y. So for these other three tables, if they're proportional, you have to be able to tell me an equation.
Wait. It's every time.
Has to work for all of them. Can't just work for one or two. It has to work for every situation that you see. Cut these out, baby. What is wrong with you? Other funny ones. Question or answer? Okay.
If they're not proportional, do we just write no?
Yeah, you just write no. All right, Noah. For the the second one on your guys' page, but on the left of the smartboard here.
It's
Yes,
yes.
and then what is our equation? How does y compare to x?
Times 0.5.
Yeah, so we could say y is 1/2 of x. 4 is half of 8, 3 is half of 6, a fourth is half of a half, and 5.5 is half of 11. Peyton, what about my second situation there, or the next situation?
What was it? I don't know about the third one.
So, what do you think the equation would be if it's proportional?
If it was, then it would be y equals 3x.
Yeah, it'd be y equal to 3 times my x. So let's check it. Times 3 works.
Yeah.
Times 3 works. 4/9 times 3, Nate.
So I made it like a fraction thing, and I got 12/9, which simplifies to 4/3.
Or we can cross simplify right here. Cross reduce, that could become 3, that could become 1. It is 4/3, so that one does work. And then this is actually 4/3. So then if I multiply that by 3, it is 4. So all of these check out. It is yes, and it is y equal to 3 times x. Lily, what about my last one there?
Okay, I put y equals 4 plus x.
Ah, so that's the thing. We take x, actually, so x is actually 4 plus y. I think you kind of switched it around. So if I add 4 to my y, if I add 4 to my y, if I add 4, if I add 4, here's the thing. That tells me x is y plus 4 or y is x minus 4, but that's not proportional because it has to be multiplied by something. So if you add or subtract something, it's not proportional. It has to be multiplied. And if we look at the first step, well, here I could say y is equal to half of x in my first step right there. But then 3 is not half of 7. 2 is not half of 6. And 1 is most definitely not half of 5. So it all falls apart. You have to have some kind of constant multiple, and it doesn't work. Questions on that? That's really funny. This printed over to the next page, which I don't know why it did that.
That's so funny.
Because the last time I printed it, it didn't do that. So try the got it. Is that last table flipped to the back?
Oh, there's no got it. It's
Well, it says, so do you get it? Yeah. Some of the notes I write my own stuff in. Some of the ones I just cut over. And we kind of need to speed up. So, anyone have our answer here? Pranav?
No, because the thing that relates to each other isn't there.
Yeah.
They're not proportional.
Here's what we can see. This, I go times 5 that direction. Here, I go times 5 this direction. They can't go different directions. So what I really have is divided by 5, then times 5, then divided by 5, and then times 5 again. So it keeps alternating with the 5s, but it is no, they are not proportional. Now, if we have a situation where we have copies and cost. Now, most of you guys probably don't know about things like this, but it used to be, like if you didn't have a printer in your house, you'd like go to the library or somewhere to go print things. So we have a table here that shows the cost and the related number of copies. So I'm going to say, is this a proportional relationship? In almost any situation that involves cost and quantity of something, you want to do dollars per whatever it is. But here if I do dollars per copy, that's going to be like small number divided by really big number. So we could turn it around and we could just ask, what is the copies per dollar in each situation? So if we do copies per dollar, it's going to be, this will be our y, that'll be our x, and then this would be our, like our y divided by our x. So if we do 150 divided by 18, we get 8 1/3. So we can get 8 1/3 pages for $1. I'm going to jump to the bottom of my table just because I would have to check every situation. So what if I do 1050 divided by 84? Here when I do this division, that actually comes out to be 12.5 copies per dollar. Is this proportional? No. The divisions were not equal. Can anyone guess why I got more here than I did up there? Zach?
Just a guess, but don't companies and stuff, like if you buy more at once, then
Yep.
they tend to give you like a discount.
That's
or, like,
exactly it.
Or like buy this many and you get this many free.
And here, this would actually be 10. So this is still 8 1/3, I think, if I remember the math right. So this company, let's say it's like Kinko's. You go to make some copies at Kinko's. Maybe they have a price for up to 500, 8 1/3 copies per dollar. Then above 500, 10 copies per dollar. Then above 1,000, 12.5 copies per dollar. Like as you buy more at one time, I love how you said that, they'll give you a deal. They'll give you a cheaper price. No?
It's funny at some like clothes places where they like sell suits and stuff.
Yeah.
You'll see those commercials where they're like buy three get one free or something.
Yep.
They're like $1,000.
I talked to the guy at Men's Warehouse about that actually. And yeah, I know you guys think I make this stuff up, but I'm serious because I just strike up conversations with people about the math. They are not allowed at Men's Warehouse to discount the price of a suit. However, they can give things away for free. So their deal is like buy one suit at full price, get one free. Or something like, instead of saying, oh, we'll give you 50% off your suit, they have to sell the suit at the standard price and then they can give stuff away for free with it. So actually some places will run crazy sales where it's like buy 2 suits, get 3 free, or like insane deals. But it's because they're making so much profit off the 1 suit or off the 2 suits, and then they can get away with it. Zach?
So this is gonna sound really strange, but I have a snake and I feed it live rats.
Slytherin!
So I have like this little like thing where every time you go, if you buy 10 rats, then you get 1 free. So like it's
What?
in my dad's
It's like a
wallet.
frequent rat card or
So
something.
like every time you go, they check it off or whatever. So it's in my dad's wallet, and like if he's trying to give like someone at a drive-thru or whatever his credit card, then he'll like say it out loud like, oh, here's my rat card. Here's this. And then
That's pretty funny.
it's
So gross.
Alright, so we're going to jump on into 8-2. Anyone solve that last got it and find out if the heartbeats were proportional?
Oh, they're not.
Yeah.
yeah,
Yeah, they are. Yeah, because it's your heart. Your heartbeats should be proportional to the amount of time.
Come on, Tyler. Unless you have
Arrhythmia?
ventricular.
What is that?
Yeah, unless you have a heart condition like I do. Were there an extra copy of notes for Seth? For the first ones? On the first one? No, then the other one should go back to. Do you have an 8 too? Okay, now. What's up? Yeah. I dropped them at everyone's desk. Oh, you were at the back table. I'm confused though, because I should have. Oh, these must be sets.
Yeah,
Yeah, I'll have to save those for him. We're gonna skip the launch. Actually, we'll do the launch real fast. So, to visually see what we talked about with that paint situation, here's a graph of making our granny apple green paint. So to go on a little bit of a tangent, when I was in high school, swerved to miss a deer, crashed my car, a little bit of damage, had to get it repainted. The paint color, when they go to repaint it, they never, well, depending on where you take your car, they never try to match the factory paint. Because I was like, oh, you can just repaint the hood. And he was like, I can't, it won't look right. I was like, what do you mean? He said, I can't match that. That paint's like 10 years old. It's faded. So even if I found out the ratio that the factory used, I can't match it because it's not that real color anymore. So he repainted my whole car. The color of it was literally called, how this is granny apple green, the color that my car, like I had a Honda Civic back in high school, it was called Arrest Me Red. Literally, it was such a bright, vibrant red color. It was called Arrest Me Red, based on the ratio of how they mix it. So I was like, thanks, Tom, my mechanic Tom at the time. It's like, thanks, man. You just gave me the color Arrest Me. So then I always drive safe anyways. But I was like, I can't get away with anything. My car looks like it's on fire right now. So the big thing here is what we see right here is that 0, 0 point. You will always, if you're making 0 of something with 2 items, you'll use 0 of both items. It's like making 0 chocolate chip cookies. Where you need 0 flour and 0 chocolate chips. You're not doing anything. But then as you go up the graph, notice that these points would all be proportional. So look at this point right here. 10 compared to 6. If I keep going up and double that, 20 compared to 12. If I keep going up and triple my original value, I have 30 and 18. They'll always have that proportional relationship.
So,
Yeah?
with this, since the slope goes through the 0, 0,
Yeah?
you know it's going to be proportional.
That and something else. So you're right, the origin point is part of it. So this is why we skipped the heartbeat one, because it is here on these notes. So if we check out...
A graph can also be used to show a proportional relationship between...
If we check out our table from the last part of the lesson like that we just ended, and we have heartbeats compared to time, and we plot all those points on the graph. If you were to check your pulse, and because you're so impatient, you wait 0 seconds, how many heartbeats do you think you'd be able to count? 0. Yeah, you're not dead, you're just impatient. So this 0, 0 point has to happen. On your notes, it says a proportional graph will be a blank blank. The next blank says that goes through the, and that's origin. The two things that we need to be a proportional graph is we have to have the origin as one of our points. We have to have 0, 0, and it must be a straight line. So on your notes where it says a proportional graph will be a, it will be a straight line that goes through the origin. Or you can put 0, 0 point, or however you want to try to remember that. But we call it the origin. Yeah.
So can it still be proportional if you go through the origin?
What do you mean? Can it still be proportional if you go
If
through?
it doesn't go through the origin, would it still be proportional?
Well, what did I just say? To be proportional, it must.
Okay, it has to go through the origin.
Yeah. It's a straight line passing through the origin.
Okay.
Has to have both of those. If it's a straight line that doesn't pass through the origin, it's linear but not proportional. If it's passing through the origin but not a straight line, I mean, like we have, so there's graphs that do this, called parabolas, where as time goes, we get more and more and more faster and faster and faster. So that's like the relationship of squaring. When you look at the areas, the graph of areas does a graph that looks like that. It's not a straight line. Parabolic relationship, which makes you sound really smart. We've got a parabolic relationship when we compare the area to the sideline.
Oh, I do these.
So, using cards. Grace, what do you think? Graph A there, is it proportional? So check, does it have a straight line?
Yes.
And does it go through the origin?
Yes.
So, this one is.
Chess.
Seth is absent. Shahid, what about B? Why?
Because it does not go through the origin.
Yup, there's no origin point here. And class, last one.
No!
Why not?
It's not a straight. It's not a straight.
So here's, some people like get in this kind of like mental argument of, but my line is straight from here to here, and then my line is straight from here to, no. It needs to be one continuous straight line. So you could put that there's a kink here. It changes directions. Or it's broken. Or however you would want to say that. Yeah. What? Yeah, it just didn't connect. Yeah, that's a lowercase k. It's supposed to be this, but I write fast.
It's like a T and an R.
I'm so sorry. You guys don't even write in cursive anymore, so I don't want to hear it.
I read my name.
I love second grade when we just got the whole giant packet of the alphabet.
You guys realize that back when I was in like
We had
5th
to
and
finish it by
6th grade,
tomorrow.
we wouldn't get credit for a paper if we didn't write it in cursive.
I'm so
I did that
sorry.
in fourth grade.
So what about this graph?
Oh, I know.
It is not on your paper, but it's pretty easy. Carrie, can you tell us whether or not this is proportional? No? Why not? Yeah, it doesn't go through my origin point. So this is a straight line, but it doesn't go through the origin. So this would be a no. Now flip to the back. I already kind of gave this away because we're working through this lesson quick. Your friend claims that that graph is proportional. Your response to that friend, now I'm not calling him just because of that. Peyton?
No, because it's not a straight line.
Yep, no, because it's not a straight line.
Those cards have never called me. You know that? They never have. Or they're named my friend.
I know.
Hey, check this out though. What is 2 squared?
2 squared is 4.
What's 3 squared?
9.
I knew that.
This is the graph of area. So this would be area compared to side length
Oh, I see you.
of a square. So this graph we could title square area. So like I told you, it has a parabolic relationship. That's where it is.
Such big fancy words.
So then what if we're given the relationship and we have to make the graph? Now, when a graph is unlabeled, like I so kindly put an unlabeled graph on your paper for you there.
Thank you.
When a graph is unlabeled, we can decide what to make the axes labels. So here it says my y value 6 times my x value. I could start by making a table. My x value compared to my y value. I know that my y is 6 times the x. So when x is 0, y is
6.
0, because 0 times anything is 0.
Zero.
When x is 1,
It's 6.
x is 2,
That's what I meant, guys.
12.
x is 3.
18.
18.
18.
24.
So now when we're deciding the scale of my x and my y axes, x, obviously, start at 0, go up by 1 is the easiest thing to do. What about my y though? My scale is undetermined. Jackson?
I think personally, I think we should go up by 6s because it's just easier because if every I don't know what to call it, 1 unit for little cubes, if it's 6, then all you have to do is match it with and it's just easy.
Yeah. So Jackson said, if I want to make this easy to graph, when I go to my x equal to 1, let my y end up on the line. So just make the line represent 6. When my x equals 2, let my y end up on the line at 12. When my x equals 3, let it end up at 18, 4, and 24, 5, and 30. So again, my y here is 0. If my x was 0, we do have y being equal to 0. Is this a proportional graph?
Yeah.
Yeah. It's a straight line that passes through the origin. Zach?
Do you need to have a 0 on both axes?
No, as long as your graph is not broken. That's a really good question. You will occasionally see graphs that don't start at 0. Like the x might start at 0, but the y starts at a value. Which actually, there was like a thing going on the internet about Fox News, and they had like an incorrect graph showing because it said like we didn't meet the goal for Obamacare or something like that because we surpassed the goal, and the graph looked really bad. Somebody had actually messed with the stuff just to like, because people like hate on Fox News. But that's like where you are be careful about graphs that don't start at 0 because then they'll look weird. Like in your head, it looks weird when a graph doesn't start at 0. The sizes of things
Would
look kind of off.
be one that doesn't start at 0 because you don't have to have something that has 0.
Yeah, but that's not always like an XY grid sort of thing. Yeah, we might wrap up the rest of this tomorrow, but you'll be able to do your homework. So you guys are good. Have a great day.
I have the time.
Thank you.